In today's data-driven world, organizations face a common paradox. As data volumes explode, the standard approach, compress data for storage, then decompress it for analysis, piles on delays, hardware strain, and costs. To overcome these challenges, we've developed a breakthrough that flips the entire workflow on its head, which is direct computation on compressed data. Typically, analytics pipelines treat compression as just a storage trick. Data goes in, data is shrunk, and then the system has to re-expand it all before it can be processed. It's like packing a suitcase meticulously, only to dump everything out again as soon as you arrive. This back and forth leads to performance bottlenecks and underutilized hardware, especially GPUs, FPGAs, and other accelerators that end up waiting for data to finish decompressing. Our solution tackles this problem at the root. Instead of going through decompress, then analyze cycles, we blend compression and computation into one fluid process. We call it a rule-based compression model. Essentially, whenever the data contains substrings or patterns that appear multiple times, we turn those repeated patterns into grammar rules in a context-free grammar. Each rule is then represented by a simple identifier, so the overall dataset becomes far more compact. You can visualize this compressed data as a directed acyclic graph, capturing all the repetitions in a neatly structured form. This design lets us perform queries and analytics while the data is still compressed, resulting in real-time analysis, a lighter resource footprint, and the full utilization of modern hardware. Building on our algorithmic breakthroughs, we've expanded our approach to both hardware and system design, unlocking new levels of efficiency in data processing. On the hardware front, we tailor optimizations to leverage the unique strengths of GPUs, FPGAs, and non-volatile memory. Instead of treating compression as a bottleneck, we integrate it directly into each device's workflow. By aligning our compression rules with native data handling mechanisms, we unlock smarter thread scheduling, adaptive memory management, and high-efficiency parallel execution, achieving 2 to 5 times faster query speeds compared to traditional decompress-first approaches. On the system side, we ensure seamless integration across multiple layers of data infrastructure. For the database, we develop CompressDB, embedding compression-aware logic at the file system level, allowing SQL and NoSQL engines to accelerate without major modifications. For graph data, our compressed graph framework encodes repeated structural patterns, dramatically speeding up large-scale traversals and social network computations. For real-time string processing, CompressStringDB keeps data compressed throughout the analytics pipeline, dynamically adapting to incoming data in real time. Beyond databases, we extend our compression-driven computation to machine learning workloads, optimizing both training and inference by reducing data movement and memory overhead. The result? Nearly 4 times system throughput improvement and around 70% memory savings, pushing the boundaries of what's possible in data processing. These innovations aren't just theoretical. They're delivering tangible impact across industries. Our collaboration with Tencent Cloud's TDSQL has driven $20 million in annual savings, cut storage costs by roughly 30%, and boosted overall efficiency. Meanwhile, on Alibaba's Pi platform, machine learning workloads saw a 14% reduction in operational overhead. We've also partnered with 7 database companies and 7 banks to deploy our framework in diverse real-world scenarios. Along the way, we've secured 10+ Chinese patents, 1 PCT, and 1 US patent, while publishing 30+ papers in top database conferences and 10+ papers in the system area, underscoring the strong academic and industry validation behind this approach. Think of it as a fundamental shift. Rather than focusing on compression as just a space saver, we use it as a strategic enabler of performance. With no decompression step, modern hardware can run at its peak, leading to faster, more energy-efficient processing, lower costs, and a clear path to real-time data insights. If you're ready to take that leap, we'd love to show you how compression-driven computation could transform your analytics pipeline. Thank you for watching, and we look forward to partnering with you on the future of data analytics.